Question. Design a DFA over the alphabet set A, B such that every string accepted contain a substring AB. So let's begin the solution. Step 1 we already know is to define the language. Define language. The language will contain all possible valid string. So we first begin by defining the smallest valid string. The smallest valid string is AB. Here we have to make sure that all the string contain a substring AB, that is A and then B together. Okay. Next, I can have A, B, B, A, B, or A, B, A, B, right? A, B, A, B, B. Or I can have B, A, B, and so on. Here, I have to make sure that every string contains AB together. AB can be anywhere. It can be in the beginning, or it can be at the end, or in between. Right? So this is how I define my language. Next step is to construct DFA. For that I have two rules. I begin my DFA construction for the smallest valid string. Right? Next, I'll be completing my DFA by responding to all the inputs at every state. Right? So, adhering to the first rule, I first construct my DFA for the smallest valid string, which is this AB. So, from Q0 state with input A, I reach state Q1. From Q1 input B, I reach state Q2. Clear? Right? Next step is to complete our DFA. That is, every state has to respond to all the inputs in the alphabet set. Q1, Q0 has already responded to input A. It has to respond to input B now. At initial state, if I get a B, is it a valid string? No, it is not a valid string. Can I make it valid? Yes, I can make it valid because by having inputs A and B. Now, how can I get this input A and B? I know that this transition from Q0 to Q1 with input A, Q1 to Q2 with input B, I can get AB. So, even if I have multiple B's in the beginning, is it allowed? Yes. Because I know that to reach final state, I am coming across this transitions A and B. Fine. So, I put up a self loop of B over here. Q0 is responded to both input A and input B. Fine. Next state is Q1. To reach Q1 state from the initial state, I have this transition of input A. Right? Now Q1 has already responded to input B. It has to respond to A. If I get an A over here, right, which is an invalid string not present in the language, so I know that transition of A should never reach final state, that is Q2 from Q1. But can I make it valid? Yes, I can make it valid if I have a B after this. Right? So from Q1, I have a transition B which goes to final state. So where shall I place the transition of A for the state Q1? Even if I have multiple A's, I know to To reach final state, I have to come across an input B. So can I put up a self loop of input A to Q1 itself? Yes, I can do that. This justifies my case. Q1 has responded to both input A and input B. Coming to Q2. To reach Q2 from the initial state, I have input A and then B. This transition. Next, if I get an A, is it a valid string? Yes, it is valid because I have an AB substring over here, right? Even if I have multiple A's, is it valid? Yes. Am I bothered about it? No, because I have justified the case of encountering substring AB. So can I put up a self loop of A over here? Yes. Now, once again, let's check for input B. To reach Q2, I have input A, B, from initial state, A, and then B. After that, if I get a B, is it a valid string? Yes, it is a valid string because I have encountered the pattern AB. Substring AB. Even if I have multiple B's, I am still, it is a valid string and it has to be present in the language, right? So I can say that B also will reach final state. Multiple B's and my string is still valid because to reach Q2, I have this transition A and B, right? So this is how we construct the DFA for the given question, that is containing a substring AB. That is, AB has to be present in the string. It can be anywhere, that is, it can be at the end, it can be at the beginning or in between, right? Now next step is to define 5 tuples of DFA. DFA is defined by 5 tuples, that is Q, sigma, Q0, F and delta. Q is a set of finite states. So here we have states Q0, Q1 and Q2. Sigma is the input alphabet set, which is A, B. Q0 is the initial state. F is a set of final states, which is Q2. And delta or del is a transition function given by Q cross sigma corresponds to Q. Step 4 is to construct your transition table, state transition table. So here let's begin. I have inputs A and B and this is my delta. States are Q0, Q1 and Q2, which is final, and Q0 is initial state. Right? Q0 on A goes to Q1. Q0 on B goes to Q0. Q1 on A goes to Q1 itself. Q1 on B goes to Q2. Q2 on A and B goes to Q2 itself. So Q2 is my final state. I've mentioned that. Right? Last step, step 5, is to give an example. Check whether a machine works for a valid and invalid string. Right? For a valid string, it should reach final state, and for an invalid string, it should be in a non-final state. Clear? Yes. So let's begin. We'll first check for a valid string. Let's take a valid string PBAB. Okay, this is my valid string because it contains substring AB, right? So let's start from the initial state Q0. If I get a B, Q0, if I get a B, I am in state Q0. Next input is B, Q0 on B, Q0 on B stays in Q0 itself. Next input is A, Q0 on A, Q0 on A goes to Q1. Last input, input B, Q1 on B, Q1 on B reaches Q2, which is my final state, right? So at the end of this transition, I am reaching a final state, which indicates that our machine is correct, because this is a valid string and it is reaching the final state. Next, let's take up a invalid string. Let's say A, B, A, A. Okay. So this is my invalid string. So let's start. Q0 on B. Q0 on B goes to Q0. Next input is A. Q0 on A. Q0 on A goes to Q1. Next input A. Q1 on A. Q1 on A is in Q1 itself. Last input Q1 on A is stuck in Q1 state. So this is a non-final state. So the BAAA is an invalid string, and here at the end of the transition, last input A, I am reaching state Q1, which is a non-final state. So this justifies our DFA. Okay, it doesn't reach a final state for any invalid string. So this is how you should be completing your answers. You should be mentioning all 5 steps to get full marks in your exam. Given a question, design a DFA over the alphabet set 0, 1 such that every string accepted should contain a substring 1, 1, 0. So let's begin a solution. We'll first define the language. Step 1 is to define the language. The language will contain all possible valid strings. So we first define the smallest possible valid string. Since it is contain a substring 1, 1, 0, the smallest string valid string possible is 1, 1, 0. Next, I can have 0, 1, 1, 0 or 1, 1, 0, 0 or 1, 1, 0, 1, 1 or 0, 1, 0, 1, 1, 0, right? And so on. So here the language will contain all strings which contain substrings 1, 1, 0 together. 1, 1, 0 together. Right? It can be anywhere, in between, at the end, in the beginning. Right? So step 2 is to construct DFA. Right? So for that, I know the 2 rules. I begin my DFA construction for the smallest valid string first. Next, I'll be constructing, that is, I'll be completing my DFA by responding to all the inputs at every state. So let's proceed. Q0 is my initial state. I'll first construct up the DFA for the smallest valid string. So here the smallest valid string is 110. 2 on 1, 2 0 on 1 goes to Q1 state. Q1 on 1 will go to Q2 state, and Q2 on 0 will go to final state, that is Q3. Fine. The first step is done. Next step, I have to complete my DFA. That is, every state has to respond to all the inputs in the alphabet set, right? And also it has to respond only once, since this is deterministic finite automata. Now Q0 has already responded to input 1. Q0 has to respond to input 0. So if I get a 0, now a single alphabet or input 0 is an invalid string, right? So even if I have multiple 0, it is still invalid, right? Even if I have multiple zeros, it is still invalid. How can I make it valid? If I have 1 1 0, I can make it valid. Now which transition will give me this 1 1 0? Which all transition will give me this 1 1 0? Is this transition over here, that is from Q0 to Q1, Q1 to Q2, Q2 to Q3. So can I put up a self loop of 0 over here? Yes. So even if I have multiple zeros in the beginning, I know to reach final state Q3, I have to come across these 3 transitions. Fine. Q0 state has responded to 0, it has responded to input 1. Coming to Q1. Reach Q1 from the initial state, I have the input, basic input, that is 1. Right? Q1 has already responded to input 1, it has to respond to input 0. Now if I am getting a 0 over here, this is disturbing my pattern of 1 1 0. So this is not a valid string. So I have understood that Q1 input transition of 0 should never reach final. Right? Now how can I make it a valid string? I can make this a valid string if I get 1 1 0 again. If I get 1 1 0, the entire pattern, entire substring. So where will I put the transition of input 0 from Q1 such that I get this entire substring 1 1 0? So if I put up the transition of 0, input 0 from Q1 to Q0, I know I can reach final state from the transition 1 1 0. Clear? So even if I have a single, even if the input was 1 0, just string 1 0, it would be 1 0. I would have stuck in state Q0. Q1 is complete, it has responded to both input 0 and input 1. Coming to Q2, to reach Q2 from the initial state, I have transitions of input 1 and from Q1 to Q2, input 1. Q2 has already responded to input 0. Now it has to respond to input 1. If I get a 1 over here, I know to reach final state, I have the transition 0. Yes. So even if I have multiple ones in between, is it valid? Yes, it is valid because it contains the substring pattern 1 1 0. So can I put up the transition of 1 over here, yes, I can put up a self loop of 1 at state Q2. Yes. Now Q2 has responded to input 0. It has responded to input 1. The last state, final state Q3. To reach Q3 from initial state, I have input 1. One more input from Q1 to Q2 with input 1. Q2 to Q3, 0. Right? That means I have encountered a substring 1, 1, 0. So now tell me, if I get a 0 at the end, does it matter? Or if I get multiple zeros at the end, does it matter? No, because my string contains the substring 1, 1, 0. So even if I get multiple zeros, it doesn't matter at the end. Similarly, let's check for 1. So at the end, if I get a 1, does it matter? No, because already I have this substring 1, 1, 0. So even if I have multiple 1, I can say that I'll put up this self loop for input 1 as well. Clear? So this is how you construct up your DFA for the given question. Next step, step 3 is to define 5 tuples of DFA. DFA is defined by 5 tuples, that is Q, sigma, Q0, F and delta. Q is a set of finite states, that is here I have Q0, Q1, Q2 and Q3. Input alphabet set, here I have 0 and 1. Q0 is the initial state, and then F is the set of final states. Here I have only one final state, that is Q3. Next, delta is the transition function given by Q cross sigma corresponding to Q. Next step, step 4, is to construct the state transition diagram. Table. Let's start. I have input 0 and 1. This is my delta function for the states Q1, Q0, Q1, Q2 and Q3. Q0 is my initial state, Q3 is my final state. Q0 on 0 goes where? To Q0 itself. Q0 on 1. Q0 on 1 goes to Q1 state. Q1 on 0 goes where? To 0. Q1 on 1 goes to Q2. Q2 on 0 goes to Q3. Q2 on 1 goes to Q2 itself. And finally, Q3 on 0 and 1 both goes to Q3. So Q3 is my final state, let me mention that. Correct? Last step, step 5, is to give an example, that is, check your machine for a valid and invalid string. Fine? So let's take up a valid string here. A valid string can be 0, 1, 1, 0. It contains a substring pattern 1, 1, 0. So let's proceed from Q0 state. If I get the input 1, which state I am going? I am going to state Q0. Next input is 1. Q0 on 1. Q0 on 1 goes to state Q1. Next input is 1. Q1 on 1. Q1 on 1 goes to state Q2. Right? Next input is 0. Q2 on 0. Q2 on 0 goes to state Q3, which is final state. Now this justifies a string which is valid since it is reaching final state at the end. Next, we'll check for an invalid pattern. That is, let's suppose I have 0, 0, 1, 0. Right? So let's start Q0 on input 0. We'll begin with this. Q0 on input 0 goes where? Q0 state. Next input is 0. Q0 on 0. It goes to Q0. Next input is 1. Q0 is on 1. Q0 on 1 goes to Q1. Next input is 0. Q1 on 0 goes where? It goes to state Q0. So, for an invalid string, I am not reaching final state. I am reaching at the end of the transition, I am reaching Q0, which is a non-final state. This indicates that our DFA is correct, and this is how you should be writing the answer by mentioning 5 steps in your university exams.